Welcome back, my students. Today we are going to do lesson 29. We're going to talk about negative exponents and zero exponents. So here's what we already know about exponents. We know that when we have, let me get a little bit larger pen here. You can see a little bit better. We know that when we have x times x times x, all of these have an exponent of 1. It's invisible, but it's there. And all it means is x is being used here one time. And we just count the number of times that x is being used, and that would be x to the 3. That's the same thing as if you were to add these exponents of 1 together. Now, because of this, we know that we can have x with an exponent of 2 times x with an exponent of 3, and we just add those two exponents together and we get x with an exponent of 5. So we already know this about exponents. We know that it's just that variable, that letter, that unknown value, this many times. That's all an exponent is it's this many times. And we also know that when we multiply, unless we come across another variable of the same, same base, it just stays. So if I had 2x squared, 2 times 2x squared, we would just multiply the constants and the variable stays the same. So that would be 4x squared because we don't have another variable. But if we had 2x times 2x squared, we'd multiply our constants, our coefficients here, and then we would add this little 1 here to the 2, and we would get 4x3. So we already know how these exponents work right now. All right, we already have that kind of in our head. So let me show you something else. I'm going to switch colors for the new stuff. Here's something that you're going to start seeing, and that's going to be exponents that are negative. That kind of looks a little scary. How do you have a negative exponent? Well, a negative exponent just simply means that it is in the wrong fractional place and it needs to be flipped. So what this literally looks like when we write it correctly is this. We put it as a fraction and we switch it. Right now it's in the numerator. We switch it to the denominator and then it takes the negative away. And in my mind, I pretend that the negative becomes this little bar and that it takes it away in that regard. So you can almost see that, the little negative sign becoming the division sign, just gets bigger and moves up, and then you have the 1. And by the same token, if you have this, let's say it's a -4 this time, well, we flip it again. It's on the wrong side of this fractional positioning. It's in the denominator this time, so we unflip it and we move it up here. We make it x to the 4, we put it in the numerator, and because we know that any number over 1 is a whole number, it just becomes this. It's just x to the 4 by itself. All right, and technically this x to the -3 is, we make it a whole number we make it a fraction by adding 1 underneath it. That's how you turn a whole number into a fraction, and that's why we can just flip it around and put 1 on top to get rid of that negative sign. Right? So if we were to have, let me make my x a little bit smaller. Here we go. If we had 2x to the -2, we would not flip the 2 because these are factors. These are times each other. Whenever you have these variables next to each other, next to a whole number, you're multiplying 2 times x to the -2. So this would actually end up being the 2 stays on top, but then the x squared goes to the bottom and we lose the negative sign. Okay, and again, if you had 2 with x to the negative 3, that would actually become 2x3. We would get rid of the negative and move it up to the numerator. And because there's always an invisible 1 in front of variables that are by themselves, that would leave the 1 behind, and anything over 1 is a whole number. So it just becomes that little whole number all by itself without being a fraction anymore. All right. So that is what we're learning today about negative, let me clear the page, negative exponents. So I'm going to write it out for you. I'm going to write the rule. And I want you to write this in your notes because that's how you remember these things, is by writing out the rules. And it's not wanting to clear. Hang on just a moment. It has to think about it. There we go. So the rule is the definition of x to the n, that 1, it is equal to 1 over x to the positive n, and 1 over x to the negative n is equal to x to the positive n. And this is for where n is any real non-zero number. All right, and that is your rule. Where n is any real non-zero number. If it's a negative n, negative whatever that number is, you put it on the bottom and make this exponent positive. If it's in the denominator and it's negative, you put it in the numerator, make it a whole number, and it makes it positive. So write that rule down, remember that, for your negative exponents. That's going to be really important. All right, so let's try a couple. I'm going to switch to green. Let's try a couple of these example problems. So we have 29.1 here. I got my decimal ahead of myself. And we have 3 to the negative 2. So all we're going to do is flip that and say 3 to the positive 2, 3 to the exponent of 2. But this is not where you stop. Just flipping it is not enough. You have to go ahead and solve it. So we say 3 times 3 is 9. So we put that over 9. And that is the answer to 29.1. So let's do 29.2. We have 1 over 3 to the negative 3. Well, just like our example up here shows us, we're going to bring that to the numerator and make it a whole number. So that would be 3 cubed. All right, but we're not done. We have to say 3 times 3 times 3, which is 27. All right, let's do 29.3. Be sure to write down your example problems because that's going to show you how to solve these types of things when you come up against them on your homework. All right, 29.3 says, what is negative 3 to the negative 2? Well, we know that when we have this, we need to get rid of the exponent first. We need to take care of this exponent before we take care of this because there's no operation to perform inside of our parentheses. So when we talk about PEMDAS, parenthesis just means if there's an operation that you can perform inside the parenthesis, you do that first. Then you do any exponent. So in this case, there's no operation, so now we do the exponent. So what that means is we have 1 over negative 3 to the positive 2. And we are not done because we need to multiply negative 3 times negative 3. And the reason it's negative 3 times negative 3 and not just 3 is because this is in parentheses and the 2 is touching the parentheses, not the 3. So that means whatever the 2 is touching, that's what's included in the squaring. So negative 3 times negative 3 is going to equal 1 over 9. All right, let's do 29.4. We have some variables now, and we have a lot of them. So let me write them out here. We have x to the 4, m to the 2, x to the negative 2, and m to the negative 5. Okay, now when we have like terms within an expression, and in this case we have x's and m's, we are simply going to continue that rule that we had when we had x squared times x cubed. We would just combine those together. Well, if both of these are positive, which they are, then we just combine a positive 2 and a positive 3, and that becomes x to the 5th. But when we have negative exponents, we treat them the same way. We just combine them with their sign. So if we have x to the 4, x to the 2, what that ends up being is x to the 4 minus 2. And we have m to the 2 and m to the negative 5. So m to the 2 minus 5. We just combine those exponents, okay, with whatever sign they have. So 4 minus 2, that becomes x squared, and m 2 minus 5 becomes m negative 3. Well, if we want to get rid of the negative exponents, which we don't like in algebra, by the way, then we just take this m to the denominator, and we're left with x squared over m to the 3. And that's as far as we can go because we don't know what the value of x and m are. So let's try 29.5. So we have a whole lot of variables here that we're going to put together. We have 3 different ones. We have x to the negative 2. Let me write that better. Y to the negative 6. Y to the 5, to the 5th power, I should say. X to the 4th power. Z, x, and z to the 5th. Now remember, when we have a variable by itself, it's to the 1 power because it's being used one time in this location. When there's no exponent, it's just being used once. So we put that little imaginary invisible 1 right next to these exponents, and it helps us to see what math we need to do with these exponents. So let's put all our x's together. So we have x to the negative 2. Okay, we got that one. Cross it out as you go through it. It'll help you remember it. We have a positive 4. And we have a positive 1. All right, now we have y to the negative 6. We have y to the positive 5. And that's all we have for y. So let's see, we have z to the positive 1 and z to the positive 5. Now we can solve this. So negative 2 plus 4 is 2, plus 1 is 3. So we have x to the 3. And we have y, negative 6 plus 5 is going to be negative 1. And then we have z, 1 plus 5 is going to be z to the 6. Well, now we have this negative 1 we need to deal with. So this becomes x to the 3, z to the 6, but y goes to the bottom. And because that 1 right here, it's just being used one time, we don't have to put that 1 there. It's invisible. It's always understood that there is a 1 there when we just write the y one time. Okay, so you don't have to put the 1, but if it helps you, you can put it there until you get better at it, okay? But this would be your final answer for this problem. All right. And when you're doing your homework and you turn in your practice problems or you turn in your homework problems, it'll be set to take this one or this one. Okay, so either one of these is correct. You're getting into a portion of algebra now where there are going to be multiple formats. I'm going to try to get as many of them in there as I can. I'm going to try to put all of the possible answers in. But sometimes I'm just not going to be able to. Like when you have these multiple variables, I would have to type this in as x to the 3, y to the negative 1, z to the 6, and then type it in as y to the negative 1, x to the 3, z to the 6, and then type it in as y to the negative 1, z to the 6, x to the 3, because I have no idea in which order you're going to type your answer. So what I do is I put it in the 2 possible formats, and then if it gives you the wrong answer, but you are confident you've got these correct, leave it, because I will do the comparison and I will make sure it's right. Okay? So that's something you need to you want to worry about getting the right exponent, but don't worry so much about, well, the system marked it wrong. Check your work, make sure your work is right, and I can't put in all the possibilities. So expect some of these to come back a false negative. You're going to get some of those even if you're 100% correct. Just because I'm a human being and I can't, imagine every possible outcome. So that is all we have for negative exponents. Now we're going to talk about the exponent of 0. What does that mean? So if you haven't taken these notes down, I urge you to do so. You can pause it now. I'm about to clear the page. So negative exponents. All right, so the definition of a negative exponent is this. When you have x to the 0, then that equals 1. For any real number, I'm going to put it like this. If, oops, give me a pen back. If x is any real number that is not 0, then this is true. Okay? And this is your rule. Now, this equals this. And that's a 0. Sorry. My nose was itchy. It threw me off. That is a 0. 0 to the 0 is 0. All right? All right. So you can put that in your notes as something to remember, that 0 to the 0 is 0. But for anything else, any other real number that is not 0, and that includes a variable, if we don't know the value of the number, if we don't know that it's 0, then it's 1. So let's do some sample problems that include that. I'm going to change the color of my pen so you can tell the difference. If we have, let's see here. this right here. Here's our problem. We're going to do 29.6. I had a glare on my paper. It was hard to see. That's why I paused for so long. All right. So what we're going to do is we're going to do the same thing we've always done, and we're going to add these together. We're going to take our exponents. Sorry, I didn't mean to write an X there. I meant to do this. And then we're going to add them together. So we have x to the 0 right here, because 2 minus 2 is 0. 5 minus 2 is 3. When you have x to the 0, that becomes 1, right? So 1 times y to the 3, we know it's just y to the 3. We can drop the 1. In fact, that's what most of the time mathematicians are going to drop the 1, because it's an extra step, and it's already understood through the identity property of multiplication that 1 times anything is itself, so there's no reason to put the 1 there, but it is understood that the 1 exists there, right? It's a math thing. Just go with it. All right, let's do 29.7. So this one is a lot of variables, a lot of exponents. And this is where, to me, algebra starts to get fun. It's almost like a puzzle, and you get to solve it. That's the fun part of math, is the puzzle aspect of it. It's like a challenge that you have to meet. All right, that's our problem. So we're going to distribute, of course, this to this. So we write it all together. x5, y to the 0, and this is a z. Let me put a little thing on here so you know those are all z's. All right, and that's a z. So then we have p to the negative 3 and z to the 0. All right, now we bring down our operation. We rewrite this. X to the 5, y to the 0, z, and remember that z to the 1. And now we have 4, x to the negative 5, z to the negative 1. All right, so let's do our first one here. Let's see, let's do them in alphabetical order. That tends to work. And if you'll put your answers into Jupyter Ed in alphabetical order, that's what I try to do also, which means that your answers are probably going to be marked correctly more often if you put your variables in alphabetical order. If I do that and you do that and we both agree to do that, then more than likely you'll get your stuff marked correct if the answer is in alphabetical order and the exponents are correct. So let's start with x. We have x to the 5. All right, y to the 0, cross it out. Z to the 0, cross it out. It just means 1. 1 times 1 is 1. We already have an invisible 1 here. We don't need another 1. 1 times 1 times 1 is still that invisible 1. So we just leave it. Z to the 1 and p to the negative 3. Right? On this side, we have, first we have x to the 5, and we have x to the negative 5. I did that wrong, didn't I? I meant to just do the exponent. So that's negative 5. Y to the 0, get rid of it. So we have z to the 1, z to the negative 1. Those are both done. And then we have 4 is our constant. So x to, let me do it in alphabetical order like I want to do. We have p to the negative 3, x to the 5, z to the 1, which we don't have to put the 1 anymore because we know that it's there one time. Now when we rewrite this, 4 comes to the front because it's our constant. All right, 5 minus 5 is 0, so that goes away. 1 minus 1, that's 0. That goes away. And we've already done the 4. So this is it. The only other thing that we can do to this problem is put p in the numerator, the denominator. So it could look like this. X to the 5 with a z over p to the 3 minus 4. Either one of these is the right answer. All right. So if you haven't written this down, do it now. I'm fixing to clear the page, or I'm about to clear the page. Sorry for my Mississippi grammar. Let's do 29.8, just to keep going, kind of get in the swing of things here. We've got another distribution problem. All right, so I'm looking, and the first thing I see is that when we do this distribution, x to the negative 2 times x to the 2, positive 2, that's going to be x to the 0, right? So let's go ahead and write that down. X to the negative 2, x, well, let's just go ahead and do y, because it's next. Y to the negative 2. Now we write down this x to the positive 2, y to the positive 2, plus x to the negative 2, y to the negative 2, 4x to the 4, y to the 2. All right, remember we have this invisible number 1 right there. So when we take x to the negative 2 and x to the positive 2, and we combine them, we get x to the 0. So the x's go away. When we have y to the negative 2 and y to the positive 2, the y's go away. But we still have to remember the invisible 1. We can't forget it. It has to fill this space. All right, so now we bring over our constant, which is the number 4, and we look at our exponents. We have x to the 4 and x to the negative 2. Negative 2 and a positive 4 means it's going to be 2. Now we have a y to the negative 2 and a y to the positive 2. Negative 2 and positive 2 cancel each other out, and the y's go away. So all we have left for this problem is 1 plus 4x squared. That's it. So all of this became just this. And you're going to see that happen. So 29.9 gives us 3 problems. We have A, which is 2 to the 0. We have B, which is negative 2 to the 0. And then we have C, which is negative 2 within parentheses with the 0 on the outside of the parentheses. So for A, 2 to the 0, we know that anything to the 0 is 1. For B, we know anything to the 0 is 1, and the 0 is touching the 2. It's not touching the negative sign, so this becomes a negative 1. But now with C, 0 is touching the parenthesis. It's attached to that. So whatever is inside the parenthesis becomes 1. So negative or positive, it doesn't matter if it's inside the parenthesis and the exponent 0 is on the outside. Okay? That is the difference. Look and see what it's touching. That is what tells you whether the negative is affected or not. All right, let's see. Do we have any more? Nope. That is all the example problems that we have for lesson 29. So I will see you in lesson 30.